In this video, we're just going to have a look at velocity time graphs again, but this time we're going to look at velocity time graphs that are not straight line graphs, but they're more curved, or they have curved sections in them. So to start off with, looking at this graph, you can see here at 0, you've got velocity on the y-axis, you've got time on the x-axis, and you can see that you've got 0, 0, the origin here. So at 0 time, the velocity is 0. That means the object is not moving. Okay, that's the first thing. Now, if we look then in the middle part of this graph, the middle section of this graph, perhaps from here, okay, which is 12.5 seconds, up to perhaps this point here, which is about 17.5 seconds, okay, so that's about there. Okay, so if you look between 12.5 and 17.5 seconds, in that region of time, this line here is pretty much a straight line, okay, and there's no curve to it. So what does that mean? Well, remember we said that the gradient of a velocity time graph is equal to the acceleration, okay, so between 12.5 seconds to 17.5 seconds, what we can say is that because this graph is a straight line, there is a uniform or constant rate of acceleration. So uniform or constant rate of acceleration. How do we know that? Well, instead of doing 12.5, let's have a look at 13. So at 13 seconds here, okay, if you look at 13 seconds, that's that point there, okay, so that is 13 seconds. Okay, if you look at 13 seconds and then you can see there that the velocity is 5.5. Okay, so on the graph at 13 seconds, the velocity is 5.5 meters per second. If you look then at 14 seconds, 15 seconds, and so on. So 13 seconds, 5.5. Okay, now 14 seconds is here. So if you again just use a dotted line, okay, and you can see there that at that point the velocity now is, that's 5.5, that's 6, that's 7, that's 8, that's 9, okay. So we can see that it's 6.5 meters per second at 14 seconds. Then if you go to 15 seconds, which is here, okay, and draw across, you can see again that the graph is at 7.5 meters per second. So basically what we're saying here is every time the time goes up, so this is time and this is velocity, every time the time goes up by 1 second, the velocity is going up by 1 meter per second. Okay, there's an increase of 1 meter per second for every 1 second increase in time. So because the velocity is going up by the same amount every time we go up by 1 second, or every time we go up by a certain interval of time, that tells us there's a uniform acceleration. The velocity is increasing by the same amount for every equal change in time. Okay, if you were to look at 2 second intervals, so if you were to go from 13 seconds to 15 seconds, you'd find that your velocity had gone from 5.5 up to 7.5 meters per second. Okay, and then if you were to look at 17 seconds, so that's 11, 12, 13, 14, 15, 16, 17, so 17 is here. Okay, and if you go across from 17, it's getting a bit confusing here now because we've got so much information on here, but if you go across from 17, you'll find that the velocity is 9.5 meters per second. So every time we go up, every time the time increases by 2 seconds, the velocity is increasing by 2 meters per second. Okay, so what we're saying here is if you look at a graph and for every equal interval of time that you go up by, if the velocity goes up by the same amount each time, that means that we've got a uniform or constant rate of acceleration. Okay, now the next thing to look at then is this section here. Okay, so this section of the graph here. So here, because the graph is roughly a straight line, that's uniform acceleration, okay? But in this section, the graph is not a straight line. So what's happening? Well, the gradient is increasing. The graph is getting steeper. So if the gradient is increasing, then the acceleration, rate of acceleration must also be increasing. So what we can say here is that we have a whoops, sorry, didn't spell that correctly. increasing rate of acceleration, okay, in this region here. So the acceleration is increasing because the gradient is getting steeper. That's what tells us that the acceleration is increasing. It's not a constant rate of acceleration here, or a uniform rate of acceleration. It's a rate of acceleration that is increasing, okay? Now we can prove that again if we look, for example, at 0 seconds. So when the time is 0 seconds, we know that the velocity, okay, so if we do a little table here, the velocity is 0 meters per second, okay? Probably should have put the units in the top of the table, but let's not worry about that at this stage. Then at 5 seconds, and we'll also look at 10 seconds, okay? So if you look at 5 seconds, so that's 1, 2, 3, 4, 5. So here, the velocity there is something like, that's 0.5, that's 1, that's 2, that's 3, that's 4, that's 5. So that's 1, 2, 3, 4, 5. So you can see that it's a little bit more than half, but not quite halfway between 0.5 and 1. So I'm going to say that the velocity is 0.6 meters per second. It's difficult to tell on this scale, but it's about right. Then if you go up to 10, so that was at 5 seconds. If you go up to 10 seconds, you can see that the velocity there is 3 meters per second, okay? So what's happened here? Well, the time's increased by 5 seconds, and the velocity has gone up by 0.6 meters per second, from 0 to 0.6. But then when the time increases by 5 seconds again, from 5 to 10 seconds, we have an increase in velocity then of 2.4 meters per second. That's the increase. Initially it was 0.6 meters per second. So in the first 5 seconds, the velocity went up by 0.6 meters per second. In the next 5 seconds, it goes up by 2.4 meters per second. So the velocity is going up by an increasing amount, and that tells us that the rate of acceleration is increasing. Okay, now we can then look at this final section here. In this section here, okay, we can say this. The gradient is getting less steep. You can see it's steep here and then it's decreasing. The steepness of the gradient is becoming smaller. It's a less steep gradient. The gradient is decreasing as we go along this curve here, okay? That tells us that this is a decreasing rate of acceleration, okay? So throughout the whole of this graph, the object is accelerating because its velocity is increasing, okay? It's not at a constant velocity at any point because the graph is, perhaps except for maybe down here where the graph is almost flat, okay? But everywhere else on this graph, you can say that the velocity is increasing, so it is accelerating, but the rate of acceleration is changing. In this final section here, the graph is getting less steep, so we have a decreasing rate of acceleration, but it is still accelerating. Now, let's just study that a little bit. If you look at this point here, so when we're at 20 seconds, so we'll perhaps I made a bit of a mess here of all this, haven't we? Maybe we should have done this over here. Okay, so decreasing rate of acceleration. Okay, so that's what we've got in this section here. Let's ignore that. Let's get rid of that. Okay, that's this section here. Okay, we'll call this section 1. Call that section 2. And this is section 3. Okay, so how do we know it's decreasing? Well, because the graph is getting less steep. But again, we can study this in a bit more detail. Let's do another little table of time and velocity. This time, let's put the units in the top. Okay, so after 20, 25 and 30 seconds. So at 20 seconds, you can see the velocity here is 10, 11, 12 meters per second. So it's 12 meters per second. At 25 seconds, you can see the velocity there, if you look, is, that's 25 there. Okay, the velocity there is just a little bit more than 14. I'd say it's 14.25. Okay, and then at 30 seconds, you can see the velocity there is 15. So, with this bit of the graph, we've gone up by 5 seconds. As the time has increased by 5 seconds, the velocity's gone up by 2.25. Okay, so from there to there, it's a difference of 2.25. And then when the time goes up by 5 seconds again, you can see now the velocity's only gone up by 0.75. Okay, so in the first 5 seconds, from 20 to 25, the velocity's gone up by 2.25 meters per second. And then in the next 5 seconds, from 25 to 30, the velocity is only increased by 0.75 meters per second. And that makes sense because you can see the velocity's gone up from there to there in the first 5 seconds and then there to there in the next 5 seconds because the graph's got less steep. So that shows you that initially you've got a large increase in velocity and then a smaller increase in velocity. The velocity is increasing for the whole of this part of the graph, but it's increasing at a decreasing rate, you could say. Okay, so there's a decreasing rate of acceleration.